In 8.4, we're going to be looking at simplifying and combining rational expressions. So just to recap, a rational expression is the quotient of two polynomials. And it's simplified when the numerator and denominator have no common divisors. So some examples of some rational expressions that are simplified would be x plus 1 over x minus 1, x squared plus 3x plus 2 over x plus 3. In both of these examples, I can't simplify out anything on the numerator or denominator. So since I can't cancel anything out in the top and bottom, these are simplified. Some example of some expressions that aren't simplified would be like x over x squared or 3 times x minus 3 over x minus 3. In both of these examples, I can cut stuff out on the top and bottom. Therefore, these are not simplified yet. So in example number 1, let's simplify the expression x squared plus 7x plus 10 all over x squared minus 3x minus 10. I also want to state restrictions on my x values. So restrictions here would be any values that would make the denominator of the original expression 0. So kind of along the same lines as we've done all units. So anything that makes the denominator 0 is going to be a restriction. So to start to simplify, it's going to be easiest to look at these in factored form. In the numerator, two numbers that multiply to give me 10 and add up to give me 7 would be 5 and 2. So I'm going to change that to x plus 5 times x plus 2. In the bottom, I'm going to do the same thing. Two numbers that multiply to give me negative 10 and add up to give me negative 3 would be negative 5 and positive 2. So now that I have these in factored form, on the top and bottom, I see that x plus 2 cancels out. So in simplified form, my expression would be x plus 5 over x minus 5. I know this is simplified because nothing else cancels on the top and bottom. Finally, if I want to state restrictions, again, I'm looking for when the denominator equals 0, and I'm looking at the original equation. So I'm looking before I cut out those x plus 2 values. In this expression, this equation, x plus 5 over x minus 5, works when x is not equal to 5 and x is not equal to negative 2, because both of those values would make the original equation be 0. And that would be my final answer. In another example, now we're multiplying two rational expressions together. This, again, looks more complicated than it might be. I'm going to do the same thing here where I'm going to get these into factored form, see if anything cancels, and finally state any restrictions. In the top here, two numbers that multiply to give me negative 6, add up to give me 1, would be positive 3 and negative 2. Nothing simplifies in the bottom, so I leave that as x minus 5 times two numbers that multiply to give me negative 25, add up to give me 0. Remember, this is a perfect square binomial. I could write that as x plus 5, x minus 5. And on the bottom, two numbers that multiply to give me 3, add up to give me 4, are 3 and 1. Now that I have this all in factored form, I can more easily look at anything on the top and bottom and cancel them out. So anything in either expression in the numerator and either expression in the denominator can cancel each other out. So I'm looking at this, the x plus 3's can cancel out, the x minus 5's cancel out, nothing else really cuts out here. So in simplified form, I have x minus 2 times x plus 5 all over x plus 1. Finally, I look at the original expression, see any restrictions. This expression works when x is not equal to 5, not equal to negative 3, and not equal to negative 1. And this would be my final answer. The last problem that we're going to look at today deals with dividing, and this really just adds like one half step to the beginning of the equation. Here we have 2 minus x over x squared plus 2x plus 1 divided by x squared plus 3x minus 10 all over x squared minus 1. Now, division might be kind of weird, so I want to get this to a place that's just like that last example problem with multiplication. So it's important to remember here that dividing is the same thing as multiplying by the reciprocal. So all I really have to do is take that equation, it doesn't matter which one, I always just do the second one, flip it, and now it's a multiplication problem. So now I'm going to rewrite it like this. Same expression on the left, all times x squared minus 1 all over x squared plus 3x minus 10. So again, the only thing that I did here is I flipped that second equation, and now I'm going to go ahead and I'm just going to multiply it. So the same thing as I did in the last problem. Looking at this expression, the 2 minus x, remember that you can kind of manipulate an equation how you want it or how you want to fit. So here, I see the 2 minus x. I kind of want to flip my x and my number here, so I'm going to pull out a negative 1. When I pull out a negative 1, now I can rewrite that as x minus 2. On bottom, that would be x plus 1 times x plus 1 times that expression there would be x plus 1 times x minus 1 all over x plus 5 times x minus 2. Again, now that this is in factored form, I can easily see what cuts out on top and bottom. The x minus 2's cancel, and the x plus 1's cancel. So my simplified expression is negative 1 times x minus 1 all over x plus 1 times x plus 5. And my restrictions are when x is not equal to negative 1. I see it twice, but I just have to include it in the restrictions once. So this works when x is not equal to negative 1, x is not equal to negative 5, and when x is not equal to 2. And that's it.